Hello, we will see today how to design a circuit, a simulated circuit or a working circuit on the software. Here is a alternator. All of us know what an alternator is. It's an AC supply, and we have got an CRO here also. We will see them while in action. And then we take a transformer. The transformer connect the primary to the supply, and the secondary we have got other connections to be made, and we connect a bridge rectifier across this. And once we connect a bridge rectifier, we know that we will get a pulsating DC like this in the output, right? Next, we have connected a load resistor here, and then we connected one more CRO also, and then we go over to one operational amplifier which is used in comparator mode. This we have discussed in our other audios of how do we compare the input with the pulsating voltage, and then how do we get the output. Now if you look at this and how the output we achieve output in these fashions, and we know that the output is then this particular output, which is the zero voltage output. That zero voltage output is given to this transistor, which develops me the ramp voltage or the sawtooth voltage. Is because that when this goes high, this capacitor which is otherwise charged from the supply like this gets discharged like this. That means when this output is low, the capacitor charges. When the output is high from here, the capacitor discharges through this path, and that is what is seen here. If you could see here is the zero voltage pulse, capacitor charging and capacitor discharging, capacitor charging and capacitor discharging. This is what we get. And then we go over to one more operational amplifier in the comparator mode. So this voltage, that sawtooth voltage, is taken here and then again compared with a fixed voltage in a voltage variable voltage. This voltage in fact will be coming from some output feedback. So this voltage will be varying, and we'll see that while varying this voltage how the output is affected. And this output we have taken and then connected to a transistor which is a switching transistor, and the switching transistor ultimately is connected to opto-isolators, two opto-isolators in series. In fact, it will be only one opto-isolator, since it is in the simulation software we do not have the kind of software that we require, that is the LED and diode combination software. We have used two transistor combination software in back-to-back connection here, but actually in the practice we will not use two opto-isolators. We will be using MOC 3020 or 3021, which is LED and diode combination. And this connection is like this. That means this is connected to positive. Both of them are given in series. Actually in our case, in the MOC 3021, this point will go to collector. But in this case, since we have got to simulate this, we have used this fashion where collector is connected to emitter and emitter is connected to connector, so that both direction current flow is possible, and that is how it has been made like this. Then we have to connect some triac. This is a triac, and then the load, which is a lamp, and then we will see how it works. Now let's simulate this. Now once we simulate this, we'll see. You have seen till this place. Now okay, now let us see this. Now what is happening? Now this particular, okay, now this is the right, yeah. Now this is the voltage at which it varies, and we have seen that once we vary this voltage, let's see what is happening to the output. See the output. The width is, this is the off time. During the off time it is off. During the on time only this is the output is on. And this is based on the ramp and then the level, which we have all discussed in separate audios, and that is how it works. Now if I go on this way, and finally full output, and here little less, further less, further less, further less. You can see this is the off time. As far as the LED is concerned, this is the off time, and this is how the power which is coming is less. So based on the level which is being compared here, and that is how the output goes on changing. And this is what is the firing control in an analog manner, which also can be done in the microcontroller way, but this is what is the subject that we just wanted to explain. Thank you.